Alright, so I know this is probably like a big no-no, but uh, my main goal on this reassessment is to figure out what I did wrong on the actual test or the actual assessment of Chapter 17. So I looked at it a lot and I came to the conclusion that my integrating is absolutely terrible. So uh, I pulled up some notes from my calculus classes and stuff like that, and I figured out exactly what I've been doing wrong, and I think that's going to help me a lot in this class, in general, probably every assessment. I think it's one of the biggest things I've been having problems with is how I understand the integrals and stuff like that. So uh, on the test, the biggest mistake I made was using this value here. Instead of just looking at these points A and B individually, I kind of just used R as being B minus A, which makes sense, but since I'm integrating, it's kind of silly to do that. So I just want to look at these as B and A, and that's it. You know, because here's the distance of A, here's the distance of B. That's really all we need since we're integrating. Because as you can see down here, you know, you integrate from B to A, so it takes the difference of that distance anyway, and that's what we're trying to find in this problem is the potential difference along the path from A to B, so right here. Uh, so the first thing that I wrote down, the first step I wrote is the formula we have for the potential difference, which is negative the integral of initial to final. Then you have the electric field dot dl. And so we're using two dipoles on the x-axis right here. So we're using E dipole on the same axis is 1 over 4 pi E naught 2qs over r3. So whenever, let's see, so right this step, the third step right here, I pretty much just added that into my potential difference formula. So we have that. So really, this drawing could be anything. I mean, it can be a disc, it can be a ring, whatever. As long as I put the right uh, electric field formula into this potential difference, then it's okay. It's fine as long as I use the right integration, the right A to B, I guess you could say. So the next step is the integration. So that was the main problem I was having. So it really helps me when I rewrite the um, the problem here. So I had 1 over 4 pi e naught 2 qs over r3. Well, I rewrote it. I moved the constants to the left side of the integral here. So we got 2 qs over 4 pi e naught, and also rewrote the 1 over r cubed as just r to the negative 3. So from there, once I do that, to integrate, you just add 1 to the power, which would be r to the negative second, and then you divide it by the negative 2. You divide it by n plus 1, so that would be negative 2. But since the integration is negative, there's a negative sign right here, then that negative goes away, so we're just left with a positive 2 on the bottom here. So we have, let's see, 2qs over 4 pi e naught, and then I rewrote it back to the fraction instead of the negative exponent, so I have 1 over 2r squared. Evaluate from A to B, B to A, whatever. We have, let's see, 2qs over 4 pi e naught, and then 1 minus 2 over b squared, 1 over 2b squared minus 1 over 2a squared. But since we have 2's on the bottom here, I think this is a mistake my brother made on his assessment. He just left the 2's here, which I guess would be fine, but to simplify it, we can get rid of the 2's on the bottom here, and then this one up here. So we're left with qs over 4 pi e naught, 1 over b squared minus 1 over a squared.